Hey there, welcome back to PageKey Tech. I've taken a couple months off from this channel, but I figure I'll jump back in here and just mess around with this new video concept. I've been banging around in my head the idea of figuring out some of the basics of OpenGL and how do we basically how do we draw things in OpenGL and what are the basics there. I figure I'll resurrect this education repository that I had here and just try to do some live programming and see how it works out. So we'll see how it goes. Not sure, don't really have a huge plan. I just want to get a cube on the screen somehow using OpenGL, probably WebGL, and we'll see where it goes. And there have been other projects that I've started in this repo and moved elsewhere, like the PKOS project now has its own repo, but it did start here in the OS folder. So I guess, starting in this repo and moving elsewhere if it gets bigger is just fine. So let's do that. So I'm going to just make a new folder called OpenGL Cube. Let's cd into it, and now what? I'm going to open this as a folder. Okay, we're all set. Now I'm just going to touch index.html, and I'm going to serve it up using Python. Oops. So we're going to simulate that this flat file is actually being served from a server somewhere. I'll just write hello world. And browsing as a guest so that there's nothing up my sleeve. And we'll go to port 8000. And okay, cool. So let's see what we can find out from the wonders of Google about how this might work. So we'll say WebGL Experiment. Here's some WebGL stuff. And I think we need a canvas. We'll give it an ID, and I think what we also need is a script. So let's just throw a script in here. We'll keep it all in one file to keep it simple. And I also know, reaching the end of what I know off the top of my head, but I know that we need the canvas as an element that we get in JavaScript. So we'll get it by the ID that we just set, and we will get a context for it. Canvas.getContext, get drawing context. Okay, now I need Google. Canvas, get WebGL context. Okay, so canvas.getContext, and we will pass it the argument WebGL. Good. Let's see, did that melt anything down? What's going on in the console? Is it okay? Nothing. So we're good. Let's make sure that script's actually executing. We'll say something. And we are good. So I'll commit real quick. Why not? Let's just say should I do this on a branch? Probably, right? I don't know if I should call this WebGL or OpenGL Cube or what. All right. All right, so we committed. We'll push. What did I call this branch? WebGL? OpenGL Cube? Yes. There we go. Okay, so we pushed our branch to GitHub or GitLab or whatever, and should be in good shape. So now, how do we draw something on here? How do we set the background color? I know that's the beginning. Anti-alias, depth, false. I'm going to leave all that stuff out because unless I need it, I don't even want to specify it. So let's start with this. So context. All right, so I think you can set the clear color, and that should take care of the background color. So let's see what we could do here. Clear color. So can we do ctx.clearColor red? We'll say 1, 0, 0. Maybe we'll get a red, a solid red. Not sure. Refresh. And 4 required. So I guess I need an alpha argument too. Okay, that didn't do anything. Let's specify real quick that we just need to see what the canvas looks like. So let's say that it has a width of 300 pixels exactly, height of 300 pixels, and a border of 1 pixel solid black. Okay, now at least we can see what we're working with. Now, so we set the clear color. Maybe we have to actually clear it too. So it seemed to let me execute clear color. Maybe I have to call clear. Clear. Did not work. Okay. So how does that work? Clear. Mask. Where do we get this GL thing from? Do we have to include that from somewhere? Color buffer bit. Maybe it's the context. Where is this coming from? GL. Where's GL coming from? I'm not sure. Let's try just pretending it's the same as context and see what happens. Oh, it seems to have worked, but nothing happened. So something tells me I'm doing this wrong. Perhaps entirely wrong. But I'm sure that these guys have got me covered. MDN. So what are our basics here? WebGL2. WebGL tutorial. I've been here before. I've definitely been here. I just didn't get very far. Okay, GL is the canvas, or the context. It's good. Okay. Clear color, clear. Oh, so I should probably rename this GL just so it matches their tutorials. So that's good. 0001. Oh, fully opaque. That's why I'm not seeing it, because it's completely transparent. There we go. Look at that. Okay, that's a commit. Let's do it. Get it to be red. Okay, it's a start. Now, I would actually like a black background, I think. So let's just go zeros and then a 1. Okay, now let's see if we could draw a white square. How would we do that? Do we need shaders? Probably. Okay, I'm just going to Google it. Draw a white square. WebGL. Maybe somebody already has it done. Draw a square. Okay, perfect. All right, we got some shaders. It's always fun. This is where I get lost every time, shaders. All right, so we set the viewport. I'm going to skip anything that maybe that is important. Maybe I should do that. All right, let's set the viewport. Let's see what happens. We can play with that later maybe. gl.viewport 0 0 canvas.width, that should be fine. Canvas.height. Okay, did that change anything? Probably not. No, not yet. Okay, shaders, vertex shader, I'm going to skim. I'm just going to look at the code. Okay. With the vertex ID, okay, so we actually have separate script tags for our shader scripts. So let's do that real quick. Let's say script, and they say ID equals vertex, type equals X shader, and then I'll just do a good old Shift Alt down, and I'll go fragment, same thing. Okay, so we got our 2 shader scripts, and now it's saying we're going to write the vertex shader. Vertex shader processes points in geometry of the shape we're rendering. Fragment shader processes each pixel that fills the shape. So I guess so this is another thing that confuses me, but I guess vertex shader determines where the vertices are, and hence the regions that need to be shaded. And the fragment shader shades those regions. Seems legit. Probably totally wrong on my part, but let's try it. So we're going to do the vertex shader. We're going to have a vector 2, a vertex position. which I'm guessing is a built-in, right? Every shader has a main function, parameters to the function. Okay. Oh, GL position is like our output, right? That's a special variable. A vertex position, maybe not. Void main, GL position equals vec4, a vertex. Ooh, okay, I see. So we're just passing through our vertex position and assigning 0 and 1 to what I'm assuming is the y and the z. So we're really just setting the x in our shader. We're passing in the x, I guess. And then the shader, do we really need these preprocessor things? I guess if defined, oh, embedded GL, okay. Precision high P float, okay, whatever. I'll go with it. Oop. Uniform vec4 ucolor. Attribute uniform. What's the difference again? Attributes are uniforms. An attribute is an array of data that will be processed. Okay, that's an array, so maybe a uniform is like a scalar, just one value, I'm assuming. Variables are constant. Okay. Okay. Got it. So we got the main, and we got another special variable we're going to assign frag color equals u color. So we're just straight up setting the color to one thing. That makes sense because it's a solid color. This triangle we're going to draw, I guess. Okay, makes sense. Now we have to compile them. What a mess. Okay. So we're going to say v equals document vertex shader first child node value. Okay, we'll load that script. We'll load the fragment shader same way. Okay. So I guess that's just grabbing the inner HTML, basically, the scripts, maybe. VS, okay, now we're going to compile it, or create shader, vertex shader. I hope this is similar to regular OpenGL. Set the shader source, because I guess this is a state machine, so we can't do VS dot. We have to use gl.shader source, compile shader, pass the VS again, and then FS is create shader, fragment shader. Probably having typos all throughout this. Shader source. We're going to set the source of FS to our F source. Compile shader FS. So we compiled both of the shaders. Let me see if that throws any wild errors while we're here. Nope, looks okay, surprisingly. Okay. Now, program. I don't know why they didn't save error. Create program. Oop. We're going to attach. So we created the program. Now we have to call attach shader. Give it the program and the shader we want to attach to it. Okay, makes sense. We'll attach both of the shaders. And then we have to link the program. This is like, okay. So we did that. Any errors? No, it actually looks good. Okay. Debugging shaders. Oh, they fail silently, huh? Okay, so I guess we got to check if it went okay. So, gl.getShader. The vertex shader, we're going to see compile status, and I guess we're expecting it to be, if it's non-zero, console.error, I would think. Get shader info log vs. Right. And then we'll do the same for the fragment shader. Okay, that makes sense to me. You could do the same thing for the program, okay. Except we got to do link status. Okay, so let's see. link status, and we will, instead of the shader info log, we will get the program info log. Okay. Huh, okay, let's see if any of that happened. Oh, we got something. Failed to execute get shader parameter. Oh, did I misspell something? Get shader parameter. Oop, I should have said get program parameter. How's that? Good. Oh, no, no errors. That's amazing. All right. I'm just trying to, okay, maybe we should stop there for a second and commit again. All right, where were we? So we've got a blank screen, we've got shaders and a program compiled. Now how do we make it do something? So I guess we have to give it some data to run through those shader programs. Aspect, okay, I'll just go with it. Aspect ratio, vertices, float 32 array. Huh, I guess that's built in. Cool. Negative 0.5. 0.5 times aspect. 0.5. 0.5 times aspect. 0.5. Negative 0.5 times aspect. Okay, triangle 1. Got it. Now, how's that triangle 1? And what is aspect supposed to be here? I guess 1's just a little further along. All right, so negative 0.5. I'm just going to ignore aspect and think, okay, 0.5. So that goes from 1, 2, how many? Oh, 2D. 1, 2, 3, 4, 5, 6, right? So each is an X and a Y. X, Y, X, Y, X, Y, right? So, can I draw this? Do I get an instant whiteboard? Oh, I do. That was nice. Okay, so negative 0. So we got this. Negative 0.5. We'll call that here, and then a positive 0.5 on the Y. So that's our first point. And then we have 0.5, 0.5. So that would be right about here. And then we have 0.5, negative 0.5, right about here. So I'm expecting to see something like that. Triangle 1, and then I'm guessing triangle 2 would probably complete this. In fact, maybe we could just guess the rest of these. So negative 0.5, 0.5 times aspect. So that is there. Let's change the color. So here's our first point. And our second point we want to be down here. So it's going to be negative 0.5, negative 0.5 times aspect. And then our final point we want in the same place again. So it's just going to be 0.5, negative 0.5 times aspect. Triangle 2. Let's see if we're right on that. Point. No, I'm wrong. Negative 0.5, 0.5, positive 0.5, negative 0.5, and then, so these are switched. I wonder why. All right, let's draw that. So what do we have here? We have negative 0.5, 0.5. I would say that's right there. We have 0.5, negative 0.5, positive 0.5, negative 0.5. Oh, okay, so right there. Then we have negative 0.5, negative 0.5. Okay, so it's the same 3 points, different order. Maybe the order matters, so I'm just going to leave it the way they have it. All right, so we got our vertices. Great. VBuffer. Vertex buffer. Okay. Create buffer. Bind buffer. I guess we're just passing pointers. Array buffer, vertex buffer. Okay, so we're calling this an array buffer. Buffer data. Okay, so we're going to assign some data to it's array buffer data, vertices, static draw. No clue what that means, but we'll see. And then we could say item size is 2. Num items equals vertices dot length divided by item size. So that makes sense because we were assuming XY pairs. So we got a stride of 2, I think it's called. Okay. Did I mention stride? No. Okay. So did we say use program? No, we just compiled it way up here. We linked it. Okay. So now we say GL use program, our program from before, program.uniform color equals gl.get uniform location program uColor. Interesting. So we're saying get the location of this variable inside the program with the name uColor, and that corresponds to this in our fragment shader. Okay. Why did we do that? I'm not sure. GL uniform for FV program.uColor 0 3 0. So that looks like a color to me. Setting uColor to that. So what are we saying about uniform for FV? For fragment uniform for four parts to it FV, not float vector maybe. Doesn't mention that. We get a reference to the location of the uniform variable. Keep it in a dynamic variable in the program. So we're literally just storing this in the program to keep it clean. We could put this in any variable. Okay, that's good to know. Just JavaScript lets you stick stuff everywhere. Okay, good to know. All right, let's continue. A vertex position, same thing, get a trib location. Still a little fuzzy on, oh, vertex look position. So this is setting just a scalar, a uniform. It's always the same. And then this is setting something that changes for every vertex. Enable vertex attrib array. Then we pass that attribute that we grabbed out of the program. And then we say vertex attrib pointer. Pass the vertex location, or the variable location, the attribute location, I guess. Item size, a stride of 2. It's floats, false, 0, 0. Now, what were those meaning? Where'd my IntelliSense go? Oh well. I don't know what what. Okay, so let's read this and see what it does. Okay, we assign a uniform value. RGBA makes sense. We'll move on to the attribute. Get the location. That makes sense. And we enable the attribute and assign a pointer to this attribute. Okay, we enable it and we assign a pointer. What does that do for us? Let's see. We want to use the buffer declared above. Remember the global character of WebGL functions. We called bind buffers. When did we do that? Bind buffer, vBuffer. Oh, so it knows that our current buffer, no matter what we're doing, the buffer for OpenGL right now is vBuffer. Is that what's going on here, I think? Okay. Good to know. Okay. And Which buffer or program are currently bound in use? Okay, so you got a buffer and you have a program, and they work together. You use this GL state machine to set both of them, and then you pull a switch and draw some stuff. Hopefully that's all that we need to think about. All right, so do we have any errors? That is the question. Nope, nothing yelling at me currently. Can get rid of that. Okay, we're actually going to draw something. Draw arrays. GL triangles. 0 num items. Drawing mode, okay. Fine. Use the current buffer. We bound it earlier. Call the current shader program for each attribute as many times as we specify in the last argument. This is why we calculated num items. If it doesn't have enough elements, an error will be thrown. Okay. So, I don't know what 0 means still, but num items is 2, so it's gonna, maybe it starts at position 0 in the buffer and grabs each 2 until it's done and runs them through the program. That would make sense to me. Everything went fine, you're just being a square, okay. Everything did not go fine. Oh, I forgot to save. Oh, ho! Look at that. I would prefer a pure white one rather than a green one. Ah, look at that. Now, why is it a little lopsided? I'm not sure, but that's worth a commit for me. Awesome. That's cool. We made a square. Now, my question is, why does it look so lopsided? Why is it going off the edge like that? I think it's because we're doing this multiplication by aspect. What if we get rid of that? And what if we comment out aspect? Are we using that anywhere else? I don't think so. All right, let's just get rid of that and see what happens. Ah, that's what I wanted to see. It's a little fuzzy. It's kind of strange, but okay, that's cool. Now, how do we break this? How do we play with this? So we're just setting the fragment color to U color, which is right here. Okay. Interesting. Can we animate this at all? What if I set a timeout and only draw after 500 milliseconds? Will I see a black screen and then no? That's weird. Did something go out of scope? Why did that happen? That's a mystery. Really? Did this GL reference get baked in before it was ready to go? Strange. Should I clear color? Clear. GL dot, what is it? Color buffer bit. There we go. Forgot to clear. Okay. What if we set an interval instead, and each time we redeclare that array with the vertex positions and all that? Let's see what happens if we do that. What if we... Now, where are we setting the vertex positions? I forget. Oh, it's all the way up here? This is a pain. I don't want to do all this again. I don't want to destroy this whole code thing. It's working well. Let me just reset it. All right, that's a start. That's a good start. Now, how do we do a cube? That might be for another day, but at least we got a square on the screen. So I'm pretty happy with that. I think I'll call it a day. Yeah, thanks for watching. Hopefully this helped you. If it did or if it didn't, let me know in the comments. And yeah, see you next time.